Okay, so you might be using LLMs wrong, and here's why. I'm going to show you a few snippets of code, and I already shown a few on the on other videos. Truth to be told, this is a technology; it's still emerging, it's still evolving. It is evolving at a rapid pace, but it's evolving regardless of that. If you are one of those that is afraid of missing out, here's how I would think that you can take advantage of LLMs, AI, whatever you want to call it, without taking big of a risk, okay, with a contained risk for your coding, for example. Now, everyone's expecting for AI to generate a huge amount of code. And as I said before, if you don't use it, okay, you will lose that skill. So you need to practice. So the more you code, the more practice you get. The more practice you get, the better you become at it. Okay, you can't expect to copy and paste code elsewhere and then improve your skills over time. You're likely to actually lose them as you rely more and more on something. Your mind becomes lazy. That thing can give you the answer. Why are you trying to solve that by yourself? Okay. This is the Stack Overflow issue all over. This is the people that spend more time looking for the answer than trying to figure out the answer. Okay, this is the main difference between one of the differences between a senior developer and a junior developer per se. Let's say it's the amount of effort and the amount of time required to solve a problem. Okay. It is true that we all rely on libraries, and the effort should be measured accordingly, right, with the time you have and everything else. Okay, but there are a few things that you can use LLMs for that they are quite acceptable at this point. For example, they're really good at reading code, really good at understanding small pieces of logic, at least. And they're really good with those skills. You can actually take advantage of them quite easily in two main aspects. Let's say you're working on an exploit and you want to understand how a particular API works. Okay, you want to generate a piece of code so that you can call that API. A small snippet of small proof of concept can actually be quite successful at it. But as soon as you start to have multiple operations at the very same API, we're going to see an example of that, things become a bit tricky and quite fragile, especially because abstraction is something that is very, very difficult to acquire. It requires a lot of experience and time and dedication. And so, and it's not the strong suit, at least for the time being. So an equilibrium can be found there. Another aspect that you can actually take advantage of is actually for test case. Unit testing is really important, is crucial actually in any project. And one of the main issues is the data that you're going to use to do those testings. Okay, the quality of the test case is always not just on the code, but actually on the input that you're passing. If you're sending just the input that you expect for it to pass or fail, depending on that, you might have conditions that you're not considering based on the weird inputs that are thrown at it. That's one of the disciplines of the cybersecurity. Throw something weird at it and see how it behaves, right? So we're going to switch gears here for a second, and let's see if I can do this transition. Now I'm showing something that I really don't know what is right now. So can I get this here? And let's get it to refresh. Restart capture. Oh yes, there it is. Okay, so now it's fixed. Let's get this out of the way for a second here. Let's hide it for a bit, and yeah, that's it. Okay, So let's look into this. Okay, so a while back, I was working on something with Zabbix, a proof of concept, lab-based, just don't worry. And a few iterations after, a few back and forwards, I managed to get something out of GPT. Okay, this is basically standard, something that anyone would ask. Okay, it's nothing wrong with the code that actually works. So that the focus the focus of this is not going to be that. Okay, so we have an IP address, a dummy IP address in there. We have a bunch of calls here, getting host information. These are all operations from the Zabbix API. So the goal is pretty simple. We want to so Zabbix, it doesn't have this by default anymore, but it had an API call for which you can create a task, a monetization task. And within that task, you have the opportunity to run commands. Okay, again, this is not on by default, but it used to be, so it's a pretty cool feature, especially if the monetization platform is on has this enabled, and it's using default credentials, which happens a lot. Okay, long story short, so we have small snippet here. Extracted this snippet here for an editor just so that we can take a look at it closely. So to authenticate, this would be the request for authentication. So we would expect for username and a password there, go get host information. In there's all required operations. Create the system run item. So you need to create an item that is eventually going to be executed. And then get the latest results. So this is going to be automatically executed from time to time. We also set the time for that. The delay here, we try to do it 0 seconds. It doesn't work. That way you need to add a minimum 5 or 1 second or so. And then we have basically where the issue starts to lie. Okay, code duplication. As you see here, you're going to have a lot of stuff to deal with. And this is exactly the expectation of a spaghetti code that we see there, like that in there. So we're going to authenticate. We're going to need to take the token. Then we're going to need to get the host information so that we can create an agent interface. Depending on how this result, we might need to create a run item. This is actually a condition that I'm not considering here. And then we're going to need some small error handling. There are some hard-coded dictionary items that we need to pull out to extract the item ID that we just created, right? And then we're going to need that to get the latest results. So we're going to sleep here for a few seconds, and we're going to try to fetch this. And then afterwards, the expectation is to delete. Now, there are a few issues with this. One, if the item already exists, this will break. Okay, that would be a fairly easy thing to deal with. We'll use the condition. Here, if we're unable to create the item, then we can just edit or modify it. That is a possibility. Okay, no hard, but we have tons of duplication here. So, right. We have a post request here. We have a post request here. The main difference between these two is actually the payload itself. The rest of the code is pretty much duplicated. Same goes here. Same goes there. In here, we actually have a difference between all the other calls, which is usually a bit problematic because the output of your functions in your code base changes depending on the feature, and that usually leads to bugs and issues. Once again, we're going to deal with assumptions, whether you like it or not. And the assumption will be that you have, for example, if everyone's assuming that you have the entire output, there might be conditions where you might expect something out of this that's not really there. And the authentication is also opposed. So we have a bunch, we'll essentially have an entire duplication here. Okay, now that we know how the API works, let's take that to another level. We want to try to get rid of as much code duplication as we can. If we rely on Python, there are a few things that can help us out to create something really cool. So we'll start by creating a class called endpoint. and we're going to have two class level variable names. We're going to call one client and another one method here. Okay, so APIs, you will have in the path operations, and then eventually we can break those down and call them methods of the operations we want to call them, right? And using get attribute, we can create something like this. So when we're going to call the API, the first time we can instantiate an instance of endpoint itself, and then we're going to pass the client and the method we want to call it together with the name. So we're talking about maybe a group of operations that will be the method, and then the name of the operation itself, host, create, item, create, item, delete, get, info, stuff like that. Okay. Then when we do the call operation itself, right, when we call the create operation, right, the name of the operation is where we want to actually make the request, right? That's going to be handled within the client. We're going to see that shortly. So request is going to need a method here to be passed, and then we're going to see the quarks, the remaining arguments in here. So one of the things that might happen here is the method itself. Okay, we might be talking about an HTTP method, or you can decompose the URL into many operations here. So this is the code I reuse a lot for these sort of operations. Then after the request is finished, we want to extract the output. Okay, and the idea here is to get rid of all that duplication that we have here, right? This code here and the handling of these responses, we want to find a cool way of getting this handled a bit better. So we're going to have this nested call here. We're going to pop items based on one of the arguments that is going to be passed by call. Then we're going to pull out those values and extract them and return them into a tuple. Pretty simple. Okay. Now let's go into the API itself. Okay. The payload itself has a common ground. Okay. And this is where abstraction starts to get used. Okay. So we're going to have a method here, params that are going to be passed, and then we have a condition check here if authentication checking for auth here, and then an identifier. This identifier is an incremental value that is used. Then we have a to-dict here. We're going to see how we can use that to list. Once again, we're going to see how those we're going to use it. We have a basic handling response handling here. So if it's 200, it's different than 200 and something went wrong. We want to output the error from the calling maybe, and then we're going to extract the result from there like that. And this is going to be the handle response. Okay, if there's an error, we're going to handle it right away. Otherwise, we're going to let the flow continue. So this is one of the ways I usually write things, depending on what there's an error, just handle the error first, check for the error conditions first, whatever, and then if everything goes okay, cool. Otherwise, just return as fast as you can, trying as much as possible to keep your code clean. Okay, and easy to read. Then we have the request itself. Okay, the request itself is going to have a method, so it's going to populate that to JSON because we need to these params are going to be needed to be passed as a JSON, right? So we're going to have that over there. So to JSON is in there. So we're going to have the method and the params over there. It's going to be passed, right? That would be the payload. And then we're going to make a post request. As we see in here, this is always a post request. Okay. So request, post, URL, the data, and we're solving. Okay. Handle the response will be this method right here. The results is going to be stored in results. We're going to increment the ID to 1 and see if there's any exceptions. If not, cool. We'll proceed. Okay. If we're talking about the method being login, okay, then we're going to print the authentication token just for debugging purposes. Otherwise, we're going to and store the results into auth so we can use it later on. And then we're going to, otherwise we're going to return results as well. So the results will always come out, right? If the method we're calling is login, then we're going to also affect this internal class level variable. So pretty simple code that we have here. Now let's take a look at how we can also get another get attribute use. Okay, method. We're going to turn that method into a lower. This is going to be the start path, right? And we have a sort of fish with its tail in the mouth sort of case where we're going to create another instance of endpoint. So this is basically going to compose the API call. So in this case, we're going to have as the host, and then we're going to have a /host /get. And that would be one of the operations, right? The payload for that would be a filter. So this is one of the arguments that we want, right? So the toDig here is going to help me to, there could be room for improvement here. What we're trying to do is to see if we can turn a collection of arguments that would be passed to call already as a dictionary, so that we don't have a very long method call with a bunch of arguments. Okay, and so toDig will help us out on that sense. Here we're going to do a filter equals host name. So we're creating a filter here to get the host ID and the interface ID. So we are doing this call over here. Let's go there. Get host information. Yeah, that's on here. So the result's going to be like that. So host.get, and the in the parameters is going to have these here, these arguments. This is what we see here, right? Host, get, right? Method, name, right there. toDict, and these are the arguments here. It's going to be ended up in there. So the result's going to be host ID and interface ID. How does it know that these are the arguments that we are expecting? Output. Okay, this is the variable here. So when the handling of the outputs go onto the extract, it's going to pull out the output. Okay, that's this variable over here, and it has exactly the names that we are expecting. Moving on. Okay, so the same code base, we can now do an API.item.create. Okay, same thing. Let's take a look at the example on this side here. Take a look at what we would be doing. So item.create, this would be the payload. Okay, so we have a name here, the key that is going to be used for the action we want to do, the host ID, the type, whatever, the delay, lifetime, yada 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 yada. So how does that look like here? So once again, toDict, so we're trying to compose that. The name we're going to use some formatting here, and then the CMD here, and the key we're going to use a formatting once again, because we're going to have a variable down there with the command we want to run, and then the output is going to be stored under item IDs. Okay. Once again, we need the host ID and the interface ID, and delay. We're going to put it 1 second. That's about pretty much about that, right? This is the run method, a single run method. To make one call like this, we would have to execute all of this. We're relying on the same class, right? We don't add we don't need to add any more methods to perform any operation on over the API. That's the goal. Okay. That's essentially the goal of the abstraction, right? Everything is handled somewhat generic. Okay, in this case here is where we reach the point where we were right around there. Okay. In this case, we're doing something else. Okay. If we're doing an inverted logic to check whatever or not the previous operation ran successfully. If we were not able to create, it means we're going to need to get the existing one, modify it, and run it. Okay. And this is this part here that didn't exist over there. So not item IDs. We're going to return here. This is going to be a tuple. In this case, we're going to expect only one item returning. So we're going to ignore the first one and keep only the item ID. And in here, we're going to specify the output like that. And then a host ID and the key, we're going to run it like that. So basically, we're going to keep the existing name and reuse that task once again. If this point fails, it means something horribly wrong happened, and if that's the case, we're going to exit once. So it's basically we're going to abort that operation right there. And also, we're going to return the item ID in question from the item IDs, which is tuple once again, and then we're going to basically wait for the agent to run the command by calling the history, which we're going to basically repeat things here to history one values where the results going to be items. We're going to it's an array. It needs a collection of items that you want to extract. In this case, it's only one. We're going to sort it. Sort fields. We're going to use the clock so that we can get the last one. Like that, we're going to limit the output to 1, and we're going to see if we can output this. This is a small issue here. If we run something with a lengthy output, the output will be slightly cut. But that is something that we can handle. We could have handled it if we were interested in dealing with that. Afterwards, since this is basically a proof of concept, we want to clean up after ourselves, and so we'll be willing to call the delete, right? So keeping everything clean. So in the end, to use this, we would only need to do is define a method, define the location where that would be, the username, the password, the host name for the machine in question, the command we want to run, right? That's going to be there. Client API, we're going to call it that, right? And then what's next? Okay, call API, and then user login, and then we're going to pass the username and the password. We have the result. Okay, and now we can do the run. Okay, we're going to pass the API as an argument, the host name, the CMD, and the user ID to make the calls unique, right? So this way we can see one of the ways we could have tried to leverage something like that, right? Not to produce the last step of the code, but something more polished, right? Something they can work with and actually be more generic with less code duplication. Code duplication usually leads to issues or fixing the same thing multiple times across the code, because if you made one mistake once and then you propagate that logic across the project, chances are if there's an issue in there, you're going to propagate that issue as well. And so there's this essence that we keep fixing the same thing over and over again because the code base is not it's not well abstracted. Okay. Over time, the idea is to have something that goes towards an abstraction path where it shrinks. The code base shrinks a bit, and as you do these, generally the project gets faster. the more abstraction, the better the abstraction is. Generally speaking, the faster the code will be because it would be a smaller code base. It's not always like that, but most of the time it is the case. Okay, unless you're doing something highly complex, and then the abstraction logic actually exponentially increases the amount of code that you need. In those cases, you need to find a balance. That's software engineering 101, right? Now, another example I wanted to show is from a project that I built a very long time ago. I'm actually planning on updating that as well. So I'm going to close that and pause this for a second. Okay, so dscan is online, and you can take a look at it. It's on my GitHub page. I'm planning a few updates to it. Not just dependency updates is basically what I've been doing for a while back. Now, I have a makefile. I actually happen to you can actually, I think this there's a brand that I made here, and it runs the entire test cases here. In this case, 40 tests. Everything ran okay, so just ran it before recording just in case. And chances are it's going to blow up in my face. But whatever. So we have this is a small project that I had. We built a while back when my daughter was still a few months old. And the idea is to make a Nmap distributed across several hosts and handle all those things. Resume and prioritization and a bunch of other stuff that you can see on the video that I have. Okay, so why am I showing this project? Is actually pretty simple. As I said, generating input for test cases is pretty crucial, right? And in this case, we have this project is only 77% coverage. And in some cases, the coverage goes pretty high, in others not so much. It really depends. It's easy to get 100% when the code base is just this. But regardless of that, there's a core logic that you want to ensure that is covered. So we're going to go over some of that here. So, for example, if I take a look at this right here, this is basically one of the test cases that I have for the agent handler, for example. I have here a bunch of inputs that I want to see if it's able to handle, right? And we are going to create a bunch of things here. So one of the ways to get these things to run is to use a lot of mocks and emulate a lot of stuff. In this case, I'm patching OS make tier is file, so I'm patching a lot of the APIs to speed things up, but also to be able to tell if something happened or not, right? Just the creation of sockets, it's a lot of stuff. Okay, and then we run into the specifics. So in this case, we have here the setup, in the setup here, for example, we have establishing all the POCs, mocking even the random. Okay. In this case, I actually need that to be patched as well, so that I have something that I can expect across multiple runs. And then the expected calls for in case of a timeout, for example, we have these here. Call to connect, receive one, and then receive one, and all the retrials here, and ultimately how that would look like in a call stack, the cleanup operations and tear down as well. And then we can start actually doing the tests, right? Okay, check for mock calls to connect and disconnect. This is another case here. And then eventually we start having the tests. The test, they connect. So we're going to need to create an agent. The agent is going to start. Then we're going to check if the calls for connect and disconnect actually happen. These are the calls that we're talking about here. Okay. So why did I place that into its own method? Because likely that is going to be reused elsewhere. So let's see here. Declaration and usage. Okay, we have a bunch of other uses here. Okay, this is another one, right? So instead of basically having all that code duplicated, we can take a look at that. So another case would be magic mock here. We're going to play with structs, and here's the side effect we want to declare. Once again, a timeout example. So we're going to send it a challenge. We're going to pack a bunch of information, going to the expectations, and we're going to mark a bunch of timeouts here. And then this is how that is meant to be look like. Okay. So as you can see, you could go over this. For example, get UID, which is one of the conditions that we have that the agent needs to send to the server so that the server knows if the agent is running as root or not. As if you want to do SYN scan, you actually need root, right? And so that is one of the things we want to test as well. Here, okay, we're going to mock open as well. So I'm mocking a lot of stuff in this operation. So we have all these tests, but if you can start to look at a few things. So the IP address is always the same. There's some static values here testing. So although the coverage is nice and have a pretty decent look into the client, or 64%, and we have a somewhat coverage. Okay, it covers a lot of the main logic of the operation. So you have here the authentication process mostly covered. The connect and disconnect is covered. There's some blind spots here. There, the shutdown, establishing and whatnot. But there are a few blind spots here. For example, the SYN status, which actually led me to deal with a few issues when I was deploying it for the first time. And then mock the server responses as well. We want to see how while interacting with the server on the other side, not just what we're sending, but while receiving the commands and how we deal with that. So we're also running these. So if we wanted to take this to the next level, we could have used an LLM, for example, to create us a huge bulk of inputs for each test case, so that in the end our coverage would not just be, it could be the case where it would still be 64%, but the amount of tests in the coverage, case coverage, input wise, that I would be dealing with would be actually way bigger, and that would allow us to have more confidence over how stable the logic is, or any potential errors while dealing with some edge conditions in that sense. So zooming in, and then we have a bunch of test cases here, depending on what we're doing. We're going to see if I can zoom in on something more interesting. So this is the server test logic here. We have I have created something called a namespace. We want to patching a bunch of stuff here. This is going to be the challenge that we're looking for. We're patching the socket, the urandom for the authentication tests. The socket over there, we're sending and receiving things. I'm looking for a particular test case in here. Okay, we're having in this here, I'm also testing, doing something. We can refer to this as an integration test. Although we're patching the built-in, the goal here is actually to start the server with its own thread, as well as an agent that's going to run as well to see how they interact with each other. Okay. And so that is not what we were. This is it. This is what we're talking about here. And that yellow one is just start the server, and this one I start the server and the agent as well. So you start one in the same test. Well, basically this here is something that I'm skipping for the time being. I run this after every time I change something in the end. I want to make sure that it runs instead of launching the entire project aside. I have a piece of code that actually helps me to start that and interact with it. So structures, I have, this is the test case for the structures. This is where I think, no, it's not. This is the workspace. Okay, I found it. Yeah, this is one of the critical parts here in the parsers. Found it. Okay. It's been a while since I take a look at this. Okay, so workspace, we can talk about it soon. Let's take a look at structures. So structures are a piece of one part of the modules where a lot of the operations are declared. So if I go here into models and I have here the structures here, we have basically in base structure. So this is how the status looks like. So these are the codes that it's expecting, and these are the operations. So we have an authentication operation, a ready operation. So the agent starts, it's ready to receive commands. An operation called a command, which means we're going to be receiving a command anytime soon. The status of a particular operation, and when you're ready to send a report. This is how they talk with each other, right? And then the structure itself, right? We have the opcode for the structure. That's going to be that, and the format of the structure. And there's a header where we're going to send the information. Pretty simple. Okay, we're going to see those values away, encode it, and we're going to be packing and unpacking things into structure so that we can send those across the wire. Pretty simple. Pretty simple thing. Now we have a class meta here to optimize the creation of that. And then we have the many different structures that we want to create. So this is the abstraction, right? Once again, this is the code that is going to be common across, right? It's the base definition of how a structure should look like for an operation. And these are the operations, okay? So the authentication structure, so it's going to have one slot data, and then it's going to have this. The format is going to be 128 S. So string, that's going to be the size. Operations, opcode, auth, okay? Cool, simple. Okay, the rest of it is already clear. Same goes for the ready. Okay, in this case, we have I. There's might be a variable number of input here, so there's this magic that needs to happen in there. Same goes for the command, the exit status, and the report as well. Okay, so these are the structures, and these are the tests that we have for that, right? So we're going to emulate, right, the byte string, get size in here. So for example, here I'm emulating a file, and the location of that file. We're going to have a hash here being created, and then we're going to see if we can create things here. So in this case, we're trying to create a structure with a size, expected data results.data. Where does this comes from? Results, structure, create, mock. Okay, and result auth and opcode. So we're basically testing for the basic structure here. I think the structure in this case is pretty much empty. Yeah. And then we have the agent X here. Would be a nice improvement here. Would be to basically find a way to have this data populated, for example. Although we're talking about an authentication operation here. Task pack and unpack. So in here, we're trying to pack and unpack data as well. So let's go back into something more interesting. So unpacking a command here, for example, the expected command would be like that. So command, target, and a series of flags for nmap, for example. And then we would create structure, create socket, and then see if that looks like that. Okay. So building a mock. Okay. This part here is going to create. I was thinking whether or not it would be worth dealing with that. So what's happening here, it looks like a weird test. Let's dig this one up for a second here. So we have the expected command here, right? We declare this, right? The idea is to see if when we send this over the wire, if it's able to unpack it correctly. Okay, if the unpacked is if it's able to unpack it, the packing is also correct. I'm assuming that it's probably isn't that thorough with the points. So this is an improvement step that could also be made. But let's step over that for a second. Now, what we're going to do is a structure.create. So this is a class class level method, right? That method that we talked about there. And we have our mock socket right here. And in there, we pass the expected value there. Okay. What's going to end up happening is if we zoom in here, we're going to have calculate the size of the header. This is how the header looks like, right? Okay. And then we're going to have the operation size. Okay. Then we're going to retrieve the operation size from the socket. If it's 0, then something is wrong. Otherwise, we'll unpack the header in bytes. And now we know which operation we're talking about. And then we're going to take a look at the subclasses of that in order to find the right operation code. Okay, we're going to compare that. If that is correct, okay, we have the operation, and then using that, we're going to instantiate it with the sock, and this, okay, will trigger the set of data. Okay, if it's a sock, cool. If it's not a sock, it's a bunch of information that we want to unpack. Okay, and it will fall either here or there. Okay, so that's how these things are based. So we have the unpacking here. It's pretty simple, right? If we run all this here, let's cross our fingers. We can see the tests going. Right, and then we're going to test everything here. It's everything passes, and this is going to be the structures. So we're going to do structures there. Okay, so we have the authentication unpack. That's going to be there. Command unpack. That's going to be that one. Right, this is going to fall into the same logic here. Ready unpack. Report unpack. This is going to be the last one. Status unpack. Like that. Status finished. Exit status finished, and same logic applies. Okay, this one's pretty simple. Okay, not much. There's some room for improvement. There's always room for improvement in these things. These two are pretty much done. Now, the parts is where most of the heavy lifting are, because I'm doing a few things in here. So, say you have a big list of IP addresses, and after you do the you get the list of live hosts, for example, you have a bunch of holes in your ranges, right? Sorry. You want to find a way for that list to be optimized. Okay, and this is where I added a few pieces of logic to handle those conditions so that the scan is actually optimized. So one of the tasks is to try to optimize that list. So this is a case where there's a lot of room for improvement here input wise. And this is where one of those cases where LLMs would probably be would have been a great assistance. Okay. So we have my IP list. Then we're going to have a few expectations. We're going to expect the call right for it to look like that. We're going to see here is that most of it's going to end up in /32 because there are single scans. However, there are other cases, right? Let's say we have an IP in a glob format. Okay, what is a glob format? Let's say we have IP addresses, we have ranges, /16s, and there are a few of them where they're all in a row, right? So we want to optimize this list so that the agent is not scanning something. A single IP address could have been scanning a range. Short in time. So we have a big list of inputs here and in here. And the idea is to turn that big list into something that looks like this. So the 10, for example, range is actually a /24. So and we have ideally you want to split things into /24s or smaller if you dscan. This is, by default, goes with 4/24. So we have the 15 network and 16 network to 4/24s. Then we have a 4/30, okay, 4/31. And then we have one where we can't find a CRD range. In that case, we have a glob range. So this is what this name stands for here. Okay, glob format, which is basically find an interval of two numbers that can represent a range of IP addresses. So for the fourth octet IP address, and this takes a very long list into something more optimized. And this is the expected output. So this is the live targets would we wanted for it to look like that. So the expected call order should look like this, right? Inside would have a write operation for this, write operation for that, and so on. So if in cases like this, in this case, I had to come up with that information, right? I had to come up with the inputs of the lists that I wanted to test for, and I'm pretty sure, and it happened to me here and there, where I've placed ranges that basically throw a condition that I was not expecting. For example, if the last octet, the fourth octet, was different than 0, by default, the Python API that I'm calling to create these ranges, the CRD range, doesn't allow that to happen. You need to add a flag in here, right? You could save a lot of time. Okay, if you take that logic, say I wanted to have a test with this parsing logic, and you give me a collection of inputs that I can use, or even generate the test case itself, right? Generate the test method, then abstract the rest of the pieces, pull the pieces apart. So this is where I think that on the immediate time, you can actually have a bigger advantage. As for the test case, which is something that will help your code quality to improve significantly, right? You can actually make it so that you're winning time. Okay. One of the aspects that I heard a lot while I was in the development was, I don't have time to run test cases, and sometimes actually you're actually running and losing time by not doing them. Okay, because you start deploying something, running it, and then going on the browser, especially if it's a web app, and then go over the steps until you want to reach a point where you want to test, and then testing it, and it blows up, and then you put that thing to hold it again, go into the logic, see where the issue was, try to fix it, and then deploy it over again. If you count all these steps, generally a test case would be just run it, expect the output, especially if you're mocking a lot of stuff to actually isolate the piece of logic you want to test. Then it becomes really easy, right? You can store things away. This is done, that is done, that is done. Then my focus right now is this, and then you can pull apart the abstraction of that, right? And have that tested away. And in that case, it will actually speed you up, and it will make significant improvements. Now, developing and writing code, it allows for that to happen. It takes some experience, but it's not that hard. The code is on the repository. You can use it. I'm going to do some updates pretty soon, but I want to use this as a small example on that. Okay, one of the things, this is not something that I'm seeing at the time being, and I think it's actually quite fresh and a different way of seeing things to help out to solve one of the pressure points of any development project. Actually, the test cases and the input that is given to see if the logic is actually properly implemented or not, including input validation as well, right? So I'll see. I hope you enjoyed this one, and I'll see you on the next one.